Okay, so I wanted to make this video to show you how to install a Nest in an RV or a travel trailer. This is what I have set up right now. It's a Nest 3rd generation, and it works just fine. It's on cooling stage 2, which is AC high. I can go in here, change temperature, and there's it running right there. And I'll show you how I did in just a second. So this is what I originally replaced. This what was originally in there. It's a Dometic thermostat. I've got a Dometic AC up there, and if I take the cover off, this is what it looks like on the inside. It's got a positive 12 volts here, and then it's got a communications port in the middle, which is how the signal gets sent to the control board up there, and then also has a ground over here. And I was able to reverse engineer this by using a logic controller to, whenever it was hooked up, whenever this was up here originally, I had it all wired up, and whenever I would push the mode to AC low or AC high or to the fan, it would send a certain signal out this wire over here. So what I did is I hooked up the Saley logic controller to it, and I was able to record the signals. I was able to find out what the signal was being sent, and I was able to replicate it using our Arduino to send the signal. So the reason I use an Arduino is because it wasn't 12 volt system, it was 0 to 5 volt signal wire, communication wire, and so I had to use an Arduino to replicate that signal. These are the wires coming out into this little box, and this houses all the electronics in it. But first, let me show you the wires in the Nest, and then we'll come back here. So if I remove this Nest, the top piece, you can see everything that's underneath it, and this is how I have the stuff wired up. Get the RC wire. I have it hooked up to the AC line, the 24 volt AC. So it's got RC and it's got a C wire to power the Nest, and then all these wires over here, the G, the Y2, the Y1, and the W1, all controls the different modes of the thermostat. So the G is the fan, the Y2 is the AC high, the Y1 is AC low, W1 is heat, and that's all of it. Okay, so this is the inside of the box that I have everything housed in that holds all the components. It's a little messy. I wanted to get a smaller box, maybe something 3D printed, but I don't have that. I just got this at Home Depot, and it works out well. So what I have in here is there was 12 volts coming in from the original thermostat. I have that going to this thing using these little Waco connectors right here, and these just make it a lot easier to connect two wires together. So they go into here. This is a 12 volt to 5 volt regulator. This then goes to this little Arduino mini I have in here, and I'll come back to that in just a second. So I also have, where is it? These three wires, they are part of the RH circuit. So I also have these 4 relays right here, and they are solid state relays. They turn on and off depending on the state that the Nest thermostat is sending. Whenever the Nest thermostat is running, it calls for certain wires to come on. Right now it's on cooling stage 2, which is AC high, so it's calling for a fan, and it's calling for AC low and AC high. So I have that coming in here, and the part that comes in here, the input, is 24 volts, and the output on this side is completely isolated. So this is 24 volts over here, and once they complete circuit over here, it'll complete a circuit over here. And this is just hooked up to the ground on the Arduino. And whenever all these pins on here are connected to or set up as input high, so it raises the signal to high. But whenever this turns on, it quits circuit, and we have ground going in, and there's ground on here, and so the ground will go through here, and then bring these pins down to low, so that would be on. And depending on what is on, it'll send the signal to, depending on what I have programmed into the Arduino. So I know this is a little confusing, look at a lot of wires, but I'll put up a schematic and try to explain it better in that. I'll also put everything I used in this project in the video description below. Also, this wire is a 24 volts AC. It's connected to the 120 volts down below because I have the power supply control panel for the power coming down here, and I got a plug right there. So I connected the 24 volt AC transformer behind the wood, and I have it coming out in the extra wire because I wasn't sure where I was going to put it yet, and it's going in there. And I'll show you the schematic of how everything's wired up. Okay, so here is the diagram that I have from the Nest thermostat that I wired up. This might be a little bit easier to see than what I showed you earlier. So we have the 24 volt AC transformer, and it has two wires come off of it, and one goes to the RC wire, and the other one goes to the C wire. So this one goes here, but it also goes to each one of these relays down here, so to be able to clear the circuit. This little thing right here, this little junction, this one, and this one, they'll go to here. You can use one of those Waco connectors to connect them. So what I did is I connected a little Waco connector here to connect C and this relay, and then this relay is connected to this one, and this one's connected to that one, this one's connected to that one, and that's how those are all connected together. So then once you have that in there, you have these Y1, Y2, G, and W1, which is this is your heat, this is your AC low, your AC high, and your fan. So the yellow wire comes out into this relay, the blue wire comes out to this relay, and your green here and your red here, and they're all labeled what they do. And whenever these are activated, the little green light comes on up here that you saw earlier, and it closes the circuit over here. So each one of these columns right here, that's the common wire, they're connected to the ground. So this one's connected to here, and this little bump right here means that it does not intersect with this yellow wire, so they're not connected at all. They just had to draw over it. So this is connected here, and then these are daisy chained connected together. Each one of these, the NO, it stands for normally open. So whenever there's no power going to this relay, it's an open circuit, so there's nothing going on here. But whenever the relay turns on, then it closes this side of the circuit and allows the ground to be connected to one of the pins over here, one of the input pins. And so depending on what is turned on, this Arduino will read the signal wires and then perform a function of the signal. I'll show you that in a minute. And so if I just wanted the fan on low, I only have low fan, I don't have a high fan by itself because it was too loud. So I have AC low. Now Nest, the way the Nest is wired up, it turns on the AC low and the fan on. And so whenever this is D3 is low and D5 is low, it'll open a corresponding function. And whenever it calls for a heater, the heater, this relay comes on and the fan comes on. Now we don't really need it for this application, but I had to program it in a way that works with the Nest. And so whenever it calls for AC high fan, it'll turn Y1, Y2, and G on, all three of those. And that all goes to here, the Arduino. And this pin down here is D10. This is the output wire that goes to that communication port I showed you earlier, to up into the AC control. This D10 is output, and it goes up into the AC control board and sends a signal to it to tell what to turn on. And then over here I have the ground from 12 volts and the positive 12 volts just going to this DC transformer to convert it down to 5 volts to be able to power this Arduino. And that's the only reason I'm using the 12 volts over here, is just to power the Arduino. And I kind of put some stuff on here, try to make it easier, some notes and stuff to make it easier to read and understand. What I had was a Dometic single zone AC unit. I was going to replace it with this. Now, depending on what you have the same thing, the same thermostat and same Dometic AC control board. You can use this setup to wirelessly control your AC in your RV or your travel trailer. You can have it, you can remotely toggle the AC on. You can check the temperatures in case you have pets in the camper or the RV. You can ask Google to turn the AC on or turn it off or change the temperature. And that's the whole reason I did all this, because when I looked online I couldn't find anything. I looked everywhere and I found some for a 12 volt system, and I used part of I got some of my idea from this guy on YouTube that he did a video about, and he had a 12 volt relay set up, and so these were 12 volts, and whenever those turned on, it would turn each one on. But mine wasn't 12 volts, so I had to figure something else out. So this is what I came up with. There's a bunch of different systems out there, so depending on what you could do, you could probably adapt this to your thermostat. And whenever I was looking for Dometic thermostat controllers, I only found the one I have and the Bluetooth model, but I wanted something that connects to the Wi-Fi so I can monitor and remote control the temperature whenever I'm not here. So this is the Arduino code that I have uploaded to the board. It starts out with just defining the pins so that you can call them by the name and not by the pin number. So it just says AC pin low pin, or AC pin low pin is 3, and that just corresponds to the Arduino. And that's how all these are. This one right here corresponds to the output wire, and then these are just initials to variables set up as integers. We have our setup right here. So our AC signal gen pin is an output, so we define it as an output. And then all the other ones, pins 3 through 6, are input pull-ups. So you need to pull up, because if you just put input, it'll get a signal going from low to high a lot because of the AC interference in the AC lines. So you need an input pull-up to pull it up high to 5 volts, and that is considered off. And if we scroll down here, so that is the setup. And if we come out here to the void loop, that is the main function of the Arduino. And what it basically does is it reads the state of the pin, if it's high or low in here, and it stores it to a variable, either a 0 or 1, and it stores it as either low or high. So if we come out here to the main function of Arduino, this is a void loop, which means that it repeats this, whatever's in here, over and over again. And this is, it says fan digital read fan pin, so it's going to read the state of the fan pin that we defined up here. Let's say pin 5. So to read that, if it's high or if it's low, it'll store it under fan that we set up in the variables in here. So it goes through fan, it goes to AC low pin, the AC high pin, and the heat pin. And then it comes down to these if statements. If the AC low is low, and the AC high and the heat is high, then it'll turn on AC low fan. If the AC low is low, AC high is low, and the heat is high, then it'll turn on the AC high fan. And then for the fan low, AC low has to be high, AC high has to be high, the fan has to be low, and the heat has to be high. And then it'll turn on the fan. If the AC is high, AC low is high, AC high is high, and the heat is low, it'll turn the fan on. And this was just something I wrote whenever I was diagnosing it, trying to do some troubleshooting. So basically, if these are all high, nothing's running, and none of the relays are switched on. And in these if statements, this is a function to call for the low fan. This is a function to call for AC high fan, function for fan low, and function for heat. And whenever it gets one of these, it comes down here, and these are the functions for that. So AC turn on high fan is all of this. So it's like a signal, and I had to replicate it. So I went through and found the times of how long it was high and how long it was low. And it's pretty long. And here's the next function, and each one of those has a function, and it just goes like that. So AC low fan is going to be these signals, and this stuff right here is just I had some problems with it, and I was trying to figure out what went wrong, and so I was trying to divide it to make it easier to look at. And here's the function for the fan low. So basically, it'll write this. It'll send the AC signal pin, which is the output pin. It'll say low, and then delay for 533 microseconds. And so it'll stay low for 533 microseconds, and then once that is up, it'll go high for 750 microseconds, and then it goes here again, and it goes low for 529 microseconds, and it goes high for 503 microseconds, and it keeps doing that over and over again. And this is just a function for the heat to turn the heater on. Now, the heater, originally, whenever the original thermostat was in there, you could run the heat on whenever you have 12 volts on, whenever you don't have a shore power, AC power. That's because the furnace runs off 12 volts and not 120 volts. But the way I have it hooked up is the Nest thermostat needs to be powered by AC power, so that you cannot turn the heater on whenever you don't connect to the shore power. So if you're boondocking somewhere, this might not be the best option for you, but there is a way around it that you could do, a lot more expensive, and I'll show you what that is. And it's about $100, and you could connect this from 12 volts, and it'll convert it from 12 volts DC to 24 volts AC, and that way your Nest can be powered constantly from the 12 volt battery. So this is the Nest Thermostat app. It shows I'm currently home, and it says it's currently 79 degrees outside, and the living room is off. If we click here, go into here, you see it's we can see that it's currently 74, and if we click off, we can change it to heat and cool, cool or heat. And I like to keep it on cool because it never gets cold down here. And it's set to 70. And first the fan will come on, and that's what the gray screen and the fan is on. That's what that means. And in a second, it'll turn the AC on, the actual compressor, and the screen will turn blue. And there it goes, it just turned blue, and it's set the cool stage 2, which means the AC is on high fan. to help cool it off faster. And if you have any questions, let me know and I'll try to help you out. Thank you.